Hi, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences. In this video, I will be going briefly over something that is new and upcoming, and that is natural language processing. Now, if you think about what this means, you want to first start thinking about kind of how meaning, sentences, syntax, all of these things, how these are formed, and how sentence structures are created. So it does take a little bit of understanding of some basic facets of grammar, which we'll be going over a little bit momentarily. So let's get started here. What are some of the objectives that we'll be going through today? Well, in this, first will be, of course, defining sentiment analysis. Extremely important that we first understand the basics. Then I'll go you through a little bit of detail over how the process is behind the framework of natural language processing. It's really crucial that you understand not only what is going on, but how. And then finally, also explain some of the applications and detailed natural language processing that takes place. Okay, so be on the lookout for some of these applications that I'll be going over throughout this. Okay, so let me move the screen and let's go over this carefully. So, what are we expecting to find with sentiment analysis? Well, sentiment analysis is a way for us to understand through natural language processing, through understanding what the meaning of each sentence is. It's a way to discern emotion and feeling. So, this is where natural language processing, and I would argue artificial intelligence, has gone strides in being able to even detect something so qualitative and so um, abstract as emotion that this is truly a great advancement. And not only that, there are specific tools that are useful in doing this. So text blob, I'm gonna start telling you about some of these tools and naming them so that you can get used to them as we go forward. But blob is an important part of speech tagging, noun phrase extraction, sentiment analysis, classification, translations. All of these things comes under the purview of text blob. Also, you can use sentiment analysis specifically to systematically identify, extract, mine, and quantify affective states and subjective information. Affective states, it's one of those things that can be easily overlooked, but affective states are crucial because these are emotions, and especially when patients arrive at the office, one of the things that you assess, especially in a neurology setting or psychiatric setting, you want to assess for affect. And one of the things that you first do, of course, understand if they're awake, alert, oriented, but also make an observation of affect. So, affect, key is that affect is important. Let's keep going on this road and see where this takes us. So the next thing we really need to understand is the process. So I created this diagram with the notion that some of this process will become clear. Um, so these are just words right now. I'm gonna, as I move forward in this presentation, explain to you what each of these things mean. But tokenization, morphological analysis, syntactic analysis, semantic analysis, which is lexical and compositional, pragmatics and discourse analysis, knowledge-based reasoning, and then text generation. So these words may not resonate with you because this is not something that we use in common parlance. But keep in mind that these are critical terms, and I'm a big proponent of learning terminology to understand subject matter. So try to get used to these terminology as I'm moving forward. If you want to take some notes or pause this video and then go back to it, these are all strategies that you could take as I'm explaining this. So let's think about conversational agents. What do conversational agents contain? This is taking a step back and trying to identify the critical components that need to be determined so that you could complete a robust sentiment analysis or any sort of natural language processing. So speech recognition is critical. And more importantly, this type of technology actually is being used by things such as Siri. Um, if you think about OK Google, that is also another conversational agent that is being popularized, and people are using these for all sorts of applications, like trying to get quick information about certain maybe a subject matter that you're not familiar with. Um, you can use your voice to activate your phone, and from there, even without unlocking it, can ask questions. So that it actually involves a lot more than just the seconds that is taken for you to talk and the phone to recognize. There's speech recognition involved, right? There's language analysis, so the phone is quickly analyzing the language. The dialogue is being processed, information is being retrieved, and then the text is being converted. The text to speech is being converted. So these are the basic steps that are going on in devices like Siri and Google. So let's go into a little bit more about the technical aspects of the process that we um, recently went over. So the first step in that is tokenization. And I want to bring to your attention not only what tokenization is, but what are some of the important developments, recent exciting developments that have happened in just the area of tokenization. So what is it? If you're the best way to explain tokenization is if you have ever dealt with a comma separated value, a CSV file, right? And then if you wanted to convert the CSV file into an Excel file, you need to be identifying delimiting punctuation. So sometimes that delimiting punctuation may be just something as simple as space. So having spacing identified as a delimiter, it's something that is a good strategy. And if you look, Spacey Tokenizer, some of those things are actually dealing with that. But then there's alternatives. And so the idea is that we're trying to break down the sentence in ways that could be understood and discerned in natural language processing. That is the objective. How do we do that? We have to separate the sentence. So the fundamental step in both, of course, traditional natural language processing methods and methods like count vectorizer and advanced deep learning based architectures like transformers is that it's more of an iterative process. There's more fine tuning going on in some of the more recent advancements. So I'm going to be, talking a little bit more about tokenization, but I encourage you to look into those, into the transformers a little bit more. So just thinking about, some of the more important aspects of tokenization, sequence to sequence model. This is a big development. It's using recurrent neural networks, but having sequences the ability to process various sequences of sentences. This ability was only possible through recurrent neural networks, which is only has been developed in the past couple of years. So Google actually has made use of this tokenization feature, something called bidirectional encoder representations from transformers. So these are enhancements on innovations that are taking place in the area of artificial intelligence and more specifically natural language processing. Another framework that I want you to be familiar with is the Universal Language Model fine-tuning. Um, that, along with Transformer XL, are making strides and more accurately being able to um, complete tokenization. So that's enough about tokenization. We can now go into some other miscellaneous aspects of that process, but nevertheless extremely important. So there's a morphology analysis, and that simply means that the forms, the sounds that are being created, how are they being made? So there's also another term called lexeme, and lexeme versus lemma. So a lemma is an algorithmic process of determining. Um, so a lemma is actually a word um, which is based on an intended meaning. So if there's a word based on its intended meaning, the algorithmic process of discovering that is lemmatization. And that is an important part and key component of morphological analysis when you're comparing and completing natural language processing. So just a couple more things wrapping up. You have to also be considering syntax always. And so this diagram, I feel like, demonstrates all of the elements that are important, including syntax. So what are some of the ways, and so this diagram summarizes all the different types of ways that morphological analysis can take place. And morphological analysis, a lot of times, is used more generically. And so in this case, it's used very specifically. Um, so thinking about syntax a little bit more, we can start thinking also about how it looks. So how many readings do the following examples have? How many ways can you read I I made her duck. I made her duck. Do you see how the way I say it, how it's read, makes a difference? That is right there a concrete example of how some of these different meanings can be discerned just from one sentence. And the trick is for us as programmers to be able to tell the computer and be able to train the computer in some of these principles so that sentence recognition can become much more faster and much more efficient. We can't leave out in our discussion two important components that are extremely crucial, and those are semantics and discourse. So semantics, that is simply named entity recognition. So if you have, some sort of disambiguation, you're not clear what the sense of the word is, um, semantic role labeling. So how does the word play a role? What is going on with a certain with semantics? That is also another aspect that we need to take into consideration when completing a natural languaging process, natural um, natural language programming task. So finally, we have um, the discourse, and that is the final portion of this. So what type of sentence is being created here in the discourse? That is what we're trying to get at. And so this diagram summarizes all of the different components that is under consideration in a typical type of natural language processing. And as I said, there is applications from neural networks, there's applications from other wings of machine learning, but the main uh, version of this is natural language processing. What makes it so hard? I mean, why is natural language processing so hard? Just wrapping up in the next minute or so. Ambiguity, scale, sparsity, variation, expressivity, unmodeled unmodeled variables, unknown representations. All of these things make it the most difficult thing to complete. But as technology improves, these things are becoming much more efficient and much faster. So, in conclusion, there are still a lot of challenges that remain. The main challenge is ambiguity. We're needing to have more technology, more types of techniques to try to narrow down the meaning and improve the meaning. As we continue onward, as major corporations like Google and others keep working on this technology, this is becoming more and more efficient. So we can resolve this ambiguity with the resolution that all of us will do our part in improving a lot of these programs, improving some of the techniques, some of the frameworks, and these are being actively done through GitHub, which is a wonderful website. GITHUB. I encourage each and every one of you to become a member and start contributing. Um, Thank you for listening.